I just turned recording on, everybody.
Okay,
I
Matt.
think you have to accept it.
Sure. So before we continue on, though, I want to ask all the alumni if you guys have kids, grandkids, or anything like that, or that are between the ages of, let's say, 7 and 18. Anyone out there?
Yes, I have a 7-year-old niece.
7-year-old niece. All right, that works. So the one thing about this program is that it really branches all the way from K to 12, and it enables inspiration at a very young age. And the thing about STEM careers especially is that getting people interested young is very important. And that's why they have this program called the First LEGO League that's part of First Robotics. And First LEGO League really focuses on a combination of robots and then also Lego bricks. And the mashup of that is generated into this competition, which focuses on discovery and then also mechanical design. So one of the largest pieces of First LEGO League is coming together as a team to create a robot together as a group, and then compete head-to-head against other teams across your state, nation, and then also the world. And then in addition to that, every single team has to create their own project, which involves scientific inquiry. So I've seen, I'm a current First LEGO League judge, and I've seen projects that range from creating apps to help sort trash and then recyclables, and then also different programs to help senior citizens get around their hometown more easily. So these kids are really trying to find problems in the world and then change them, while also understanding the fundamentals of mechanical design, teamwork, and all that stuff. And then in addition to that, of the 3 different branches of First Robotics, which includes First Tech Challenge, First Robotics Competition, then also First LEGO League, there's a middle section, which is the First Tech Challenge. And in this, it's between middle school to high school age ranges. And this is really diving a lot more deep into the whole mechanical design aspects. These are whenever you finally get the opportunity to go into the shop, start milling parts, and then getting more into engineering, engineering design, and then also robust testing, and then also sustainability practices within design as well. Going off of that, with the First Tech Challenge, it's a 2v2 competition with a random partner, which is called an alliance between 2 teams that go head-to-head against a different alliance of 2 other teams. And these robots are about 18 by 18 by 18 inches large. And it's a really good experience that actually transitions real-life skills into a college environment. But in addition to that, there's also the First Robotics Competition, which is a little bit larger scale than the First Tech Challenge. I'll let Eddie talk about that now.
Yep, the final branch of the 3 main chunks is the First Robotics Competition, which mainly involves high school students and adult engineers as mentors. So teams have 8 weeks to design, build, program, and test a 120-pound robot. And at competition, they have, again, alliances, which is a 3v3. And 2 main goals, 2 main core values of First Robotics Competition. The first being gracious professionalism, which encourages doing high quality work and respecting other team members and teams. And the second core value is cooperation, which emphasizes that teams can cooperate and compete at the same time. Yep, and that's basically it.
All right, so with that in mind, what do we do on the college level, right? This is a pre-K through 12 program, but believe it or not, we are almost all of us at First Alumni in Robotics at Ohio State are first alumnus ourselves. Our student org was founded in 1996, and this past year alone, we actually won the Outstanding Outreach with K through 12 award with the College of Engineering, and out of all the student organizations on campus, we won the Outstanding Community Engagement Award, which really goes to show how much of an impact we have on the kids. So with that in mind, we will talk about some of our events that we run, starting with our FLL tournament. Matt?
So our FLL tournament is essentially focusing on the First LEGO League Challenge. And this past year, we hosted a tournament in coordination with the Society of Women in Engineering in Hitchcock Hall. And we had over 300 attendees. And this was a really exciting event because not only did we get to engage with young students building their robots and presenting their projects, we also got a lot more people into FIRST. Like, for example, a couple of the people that actually instruct the fundamentals of engineering courses have actually decided to become like advocates for our organization, and also become like full-time full-time mentors, or full-time volunteers, as I like to say. So it's like a really great part about it. But we can also talk about like our first robotics competition efforts as well. Okay.
All right, and so with that in mind, we are also planning to host a FIRST Tech Challenge qualifier in January 2021, and it's going to be annual, attracting over 600 attendees annually. But besides that, we also host a FIRST Robotics competition kickoff event for a lot of students as well, and Eddie can talk a little bit about that.
Yep. So every year at the beginning of the year, we host an RFRC kickoff to kick off the season for the year. We have about 20 teams attend with 275 attendees around Central Ohio at the PASS Foundation.
Yep. Also, we support and mentor 14 different Central Ohio teams to build a robot from scratch, 120 pounds. In fact, one of these teams is the Columbus School for Girls, which is located within the garage behind the Center for Automotive Research. So these students, these high school students, get exposed to all these different engineering concepts while working alongside Baja and EcoCar and all of our project teams here at CAR. So with that in mind, students can actually earn college credit for mentoring a team as well, which is something that we try to push. And, you know, we're really just trying to excite the kids. Eddie?
Yep. And we also have, with the CAR, of Robot in 3 days project teams. So basically what we do is that after the kickoff, we get together with a team of 20 college students. That can be FIRST alumni or not FIRST alumni. And we basically have 72 hours to build an FRC legal robot. The goal of this is to focus on prototyping, documentation, and strategic analysis of the game to present to the community for them to use. Another goal is to continue involvement in FIRST and strengthen our organization outreach. And lastly, is to allow our members to gain project experience and develop individual engineering skills. And every year, we also compete at the FIRST Alumni Collegiate Competition at Kettering State University in Michigan.
Yeah. So with that in mind, now we're going to transition back to you guys. How can you guys up in Michigan help us and FIRST in general and just excite the kids? In fact, the state of Michigan has appropriated $4.7 million in funds to start FIRST teams and events up in Michigan. So I bet there's a local FIRST team that really wants mentors, and that's something that all of you can consider doing. Also, right in the middle of the screen, you can see that the FIRST championship event is held at the TCF Center. So FIRST itself has over 660,000 students in 110 plus countries, but it all accumulates to the FIRST championship at Detroit, Michigan, which usually attracts over 70,000 students. So with that in mind, that is our presentation. Thank you very much for tuning in and listening to what we, FIRST Alumni and Robotics at Ohio State, do to support FIRST Robotics and teams around the Central Ohio region. Does anyone have any questions?
If you have questions, you could just you could talk verbally, unmute yourself, or if you're not comfortable with that, just put it in the chat box. All righty. Well, thank you. You guys did a great job. Moving on to our next team, which is underwater robotics. We got your screen. We have no audio. Who is presenting? Is that
Blaine, I think you're still muted.
All right, there we go. Couldn't get back to Zoom. All right, so hello, my name is Blaine Miller, and I am with the underwater robotics team. As I said, I'm a senior in electrical and computer engineering at Ohio State. So we are the underwater robotics team. What that means is we build autonomous underwater vehicles. These are just autonomous submarines that we take to a competition in California called RoboSub. The competition is an international competition with about 60 teams, and effectively it's just a large underwater obstacle course for robots. So there's that component of the physical competition and the static judging component. The robot on the right that you see there is named Puddles. That's the robot that we took to our competition last year, and we ended up getting 11th place. So due to COVID-19, the competition has changed heavily. It's no longer taking place in California, it's online. And also it's purely the static judging component of the competition. That means that we're being judged on our paper, our technical report, our website, video. And so the team's obviously disappointed that we can't be going to competition to compete in person, but the good news is we placed 5th last year in static judging, so hopefully we'll get a good score this year since we don't have to compete with the actual robot. Along with that, work is still going on in online meetings. We have Zoom meetings all the time. All of our meetings are still there. In fact, we're having more meetings over the summer because of more time. Along with that, we're trying to maintain the spirit of the team by having like dinner meetings together, game nights, Minecraft server, stuff like that, so that way we can all stay in touch, stay communicating, stay active. So also work on our robot has not completed, even though we do not have a physical competition this year. We're still working very hard to build our robot. We have our software team, our mechanical team, and our electrical team all working really hard to improve Puddles and work on future robots as well. So in specifics, our software team is working on simulation of our robot, path planning, controls, all that sort of stuff. So we're working on taking our competition, putting it into a computer, and running our robot through the competition to see how it can perform. On the left is one of our props from competition that we're building. It looks really ridiculous because last year was vampire themed for whatever reason. And then also we're working on enhancing the way that the robot works since we don't have a competition that we need to work at this year. So working on path planning, completely uprooting the way that the robot moves around in its control system, and also reanalyzing how we have it perform certain tasks. So we're effectively running the robot every single day, even though we can't be at a pool. Electrically, we're upgrading Puddles and working on future robots. We're redoing all the circuitry. Puddles did work last year, but there's always things that you can do better at. So we're trying to improve the functionality of it. And also we're trying to teach while working on projects. So we're trying to make sure that everyone knows how things work while being able to design all of these systems. And finally, our mechanical team is possibly the most busy because they're designing a brand new robot. This is what we've labeled Project Titan, and it's our robot that we intend to take to the 2021 competition. It may happen, it may not happen. It depends on how much time we're going to get to work physically in fall semester. But this is what we've planned with the goal in mind being trying things that we've never tried before, and just completely redesigning how our robots look. I'd like to thank all of our sponsors and ask if there are any questions from you all.
All righty. I don't see any questions coming in. So we'll move on to SAE Baja. Baja, Hayden.
Hello, I'm Hayden Hartman from the Baja Buckeyes team. I'm the team captain, and I'm just going to really basically lay out for you what this team really does and what the competition really requires of us. So our competition requires us to design, manufacture, and test a single seat ATV. That design needs to be versatile. It needs to complete a maneuverability course, a hill climb, an acceleration event, and like suspension or rock crawl event. It has to be durable. The main hoorah, I guess, of the competition is a 4-hour endurance race where all those aspects of maneuverability, acceleration, hill climb are all kind of combined into a 4-hour endurance race where all the cars are really put to the test to see who can complete the most laps in the competition. And then also it needs to be comfortable because the driver is going to be sitting in that vehicle for a long time. So that really, so ergonomic requirements are also very highly considered when making this vehicle. as far as the steering wheel and the seat. We also get a lot of experience with manufacturing, because we design, manufacture, and then complete the whole design cycle. So we've gotten experience machining, welding, and assembly as well. Often when we're designing something in CAD, it looks like it fits together so perfectly, but when you go to actually assemble the vehicle itself, it can be very difficult. Sometimes you put yourself in very difficult situations to assemble a vehicle that was really not very easy to assemble. So it's something that we have learned from in the past, and continue to improve our design cycle. And then we go through and test. Jig testing, creating really our own jigs to test different aspects of the vehicle. Track testing, we have a track over near the university airport. We're able to actually run kind of tests before the competition, so we can actually test through different scenarios and put it through a grueling experience before we actually take it to competition, so that we can kind of beat out any of the flaws in any of the designs. And then we're also focusing a lot on tuning our vehicle, as far as we use a CVT, a continuous variable transmission, rather than a typical manual transmission or something like that. So tuning that CVT to get everything out of the engine that we can is a huge aspect of the competition. And then also tuning the suspension components so that you can handle bumps and jumps in the best way possible. As you can see here, some of the pictures of the design cycle that I'd like to point out. We designed the frame in SolidWorks, and then through simulations in ANSYS, we're able to test the torsional stiffness of the vehicle, rear impact, side impact, different scenarios on the vehicle that we might experience, and make sure that the design that we have can withstand those different collisions. Then we actually go through manufacturing it. Welding is a huge aspect of Baja. We use TIG welding to put the whole car together, and it's definitely a tedious process, but very, very worth it in the end. And then, as you can see down here, we actually were able to conduct a torsional stiffness jig test, where we fixed the rear suspension components of the vehicle, and we're able to apply a torsional load on the vehicle, and then actually correlate that data with the ANSYS simulation that we had run. So that's just one example of what we do. As you can see, also we designed the drivetrain components. Specifically, like what I'd like to emphasize is the yoke that is part of the half shaft. Kind of designing that, creating it, and then through our track testing, our hex design that we had created broke, and we had to redesign our component. So we went to actually a spline design because we realized it could carry more torque and was just more durable in general. And we actually had to outsource that to one of our, I guess, sponsors. KK Tool was able to EDM cut the spline into our yokes. So as far as the virtual competition goes for this year, because of COVID, there was a deeper focus on static events. There's static events of a design presentation, sales presentations, and a cost report. The sales presentation I actually conducted today, where we present to a panel of judges who are acting as investors who want to invest in your company, and you're really kind of trying to show your understanding of the whole process of developing a vehicle, selling it, and marketing, and pitching to investors. It's a really good experience, especially for people who want to maybe end up starting their own business, become an entrepreneur, something like that. The design presentations really hone in on the things that you see on the right, going through all those steps of the design process, and making sure that you complete that design cycle at least once. They want to see how you've gone through, created a design, done analysis on that design, and then done testing to correlate that analysis, or realize that your assumptions are wrong and have to redo your complete design. So through this, you can obviously see there's a huge learning experience that goes through this, being able to actually oversee the whole design cycle of a vehicle. It gets you into different aspects that you wouldn't normally see in an industry where you're tasked with just a specific department or element of a company. And then also with this virtual competition, it really helped us jumpstart our design cycle for 2021, because we were able to actually really focus on, obviously, the design presentation, and really focus on these steps. And we've developed a very good plan as far as better meeting those requirements that are given by the design presentation, so that we can increase our scores in future years. It's something that has kind of been put to the side while we've manufactured our vehicle, because we have to get the vehicle done, but we've never really been able to really focus on the presentations themselves. So this has been a very valuable experience. And since our vehicle is pretty much halfway manufactured at this point, we're going to be able to make a conversion to a four-wheel drive car, a requirement that has been added to Baja this last year. But it's been moved back, so we're going to be able to actually get bonus points in the upcoming competition for a four-wheel drive design, and we're actually going to be able to utilize that for hopefully better performance in the competition itself. So obviously you're going to hear from a lot of us. You're going to hear a lot of ways you can contribute or possibly contribute to these teams here. Obviously money is, everyone will take money, but we also are looking for people who know contacts in manufacturing, because sometimes we have a lot of resources at CAR and in that garage to create the vehicle, but sometimes we do create components that require something like what we have at KK Tool, where we were able to get the splines EDM'd into the part. So if you have any manufacturing resources that you think you'd be able to donate your time to help us in a manufacturing process, we would love that. Raw material, if you know contacts of people that supply material for your company, or our different suppliers. We know teams have been sponsored by other companies and have gotten like titanium donations. It's like we don't have the money for that, and some teams are able to actually get materials that a lot of other teams don't have access to, thanks to their sponsors. So something like that would be excellent and very helpful to the team. And then obviously knowledge transfer, things that you've learned over the years that you would like to pass on to us. If you'd like to host a lecture on something, on a certain design process of a suspension or drivetrain, ergonomics, any aspect of this this competition that you'd like to help us out with, we would really appreciate it. And obviously this is all about connections as well. If you know people that can help get us internships and co-ops to farther enhance our education with hands-on work, that we're able to apply that education that we're getting here at Ohio State. So yeah, as you can see on the bottom right, that's our vehicle that we designed for this year. We got a little bit more creative with renderings and stuff so that we could actually kind of present our vehicle still in a very neat way. We could named it Brutus for this year, and yeah, we're really hoping to complete the design cycle here in the upcoming year. So thank you. Thank you all for listening. Do you guys have any questions? I think I saw there was something in the chat, but I don't.
There is a question that, well, Bob Lee asked, so all the Baja vehicles must be four-wheel drive in the future. Any limitations on the type of systems that could be used? What will be the role of electronics controls in the four-wheel drive? That's the first question.
So Baja vehicles, so this year was going to be a year where you could get bonus points for creating a four-wheel drive vehicle, and then the following year it was required to be a four-wheel drive vehicle. But this year we decided not to do that four-wheel drive because there was a lot of knowledge transfer that had to take place from alumni that had just graduated. So we just wanted to focus on really just enhancing the car that we had from the previous year, make some minor improvements rather than drastically recreating a new car. But yeah, so now it'll be 2 years from now when the four-wheel drive will be required. And And the limitations are, I mean, you get the points for aspects of the competition where you do use the four-wheel drive. So a lot of teams, I'm guessing, are going to use a four-wheel drive that can be engaged and disengaged, either manually or electronically. They've definitely reduced the limitations on the batteries that can be used in the competition to allow for more electronic controls with four-wheel drive if we would like to use some kind of electronic engagement and disengagement. I'm thinking we're going to go more with the manual engagement, but we'll be meeting with the electronic team to see exactly how far we want to push this in this first year of four-wheel drive that we're trying to do. But there's a lot of different things that we're trying to do here in the future, possibly manufacturing our own CVT or eCVT that can be electronically controlled and optimized for specific events that we compete in. So yeah, I guess that if that answers your question.
Thank you.
Yeah.
All righty, moving on to formula.
Yep, let me get the presentation pulled up.
Well, while you're pulling up the presentation, Eileen's on from the West Coast, and she says she has a contact that's a headhunter on the East Coast if students need help looking for internships. So you'll get to talk to her at the end of the presentations. Go ahead, Jacob.
Cool. All right, yep. So I'm Jacob Madgar. I'm the team president for Formula Buckeyes. We're the Formula SAE team at Ohio State. I'm the kid in this red shirt right here, standing out amongst all the black shirts. And then also Jeff's in the call. He's right here. I don't know if you guys can see my cursor, but he's on the far left-hand side of the screen. So a lot of what David or Hayden said covers a lot of stuff I want to kind of go over. Basically, we're organized. Our competition's organized by SAE. We're made up of about 50 active members. At the beginning of each year, we usually get around 100 members or so that come and join, and some of them get filtered out as school gets a little bit heavier and more intense. But our motto for the competition is design, build, and race. What we do is we build a single-seater, scaled-down Formula-style F1 car. We sit about like 60-inch wheelbase and around 45 to 50 inches in track width. Basically, what our process is, we first have a design phase. I have a little flow chart on this right-hand side right here, kind of explains what we do in a sense. But basically, we design around the rules, and we use the rules as a guidelines, and basically, we get tech inspected for those rules before our competition, so we have to be well within the limits of the rules and be able to be in a safe operating condition, especially with our chassis and monocoque designs, so that our organizations and races are actually very safe to keep all the students coming home properly, all their body parts. But basically, once we start with the rules, we go into like simulations, from structural simulations with ANSYS, from lap sims that we've developed over the years and have been working on, and then also working on some driver in the loop stuff, hopefully this year with car sim and with Jeff's help with some of the research he's been doing. And basically our general platform that we've been using for the past couple of years is a carbon fiber monocoque with a steel space frame in the rear, and we run a 600cc engine, which is from a Honda CBR. But yeah, so from that first stage right there, which is our design report, and from our sketches, we go to making our parts from composites, fabrication, welding, and machining. I have a couple of examples there. One's of us unwrapping our monocoque 2 years ago, and then some welding on the frame, and then some machining of our aluminum uprights. And then finally, we get to the racing and the testing. So that car right there was our 2019 car. That was in Canada, that picture. We compete. There's competitions all around the world, but SAE organizes ones in America and Canada. So there's events in Canada, Michigan at MIS, and then also in California this year, but that's sadly not going to happen from an in-person standpoint. Our competitions are composed of static events and dynamic events, just like Baja. We have design, which is design judges and people from industry reviewing our designs, and then cost, which is us putting our car into their own system, and then them evaluating how much our car costs and how well we've documented all our parts and their weights and our materials and how much is actually going into those. And then our business presentation, like Hayden said as well, is very similar, where they give us a pitch and we basically have to come up with a 10-minute presentation that follows their guidelines, even though it's fairly open-ended. And then our dynamic events, we have acceleration. That's basically like a drag race, skid pad. It's a figure 8, testing our lateral acceleration. Then we have autocross, which is roughly a 1 kilometer track, which for these cars is about a 60-second lap. And then endurance, which is a 22 kilometer race. That's usually testing the vehicle and seeing how well it's actually built. And roughly like 30 to 50% of teams will drop out of that race depending on the heat, because it's usually engine related stuff with cars overheating and stuff like that. And then also we have fuel economy. So that's at the very end of the endurance, we'll measure how much fuel we actually used and we get scored off of that. Yeah. So basically this year kind of got a little compromised due to COVID. So we don't have an in-person competition, but SAE did move over to Zoom, and we're holding all of our static events on Zoom. So we're having design costs in our business presentation, which this is getting some good experience right now with that as well. Presenting on this type of platform is kind of different than presenting in real life when you have a little more personal face-to-face experiences and can do stuff along those lines. But in terms of this car that we've been working on all year, we're planning to complete it this summer and then have it ready for summer and fall testing. We have a good group of guys good group of men and women that's been together for around 3 years now. And we're pretty hungry for some experience with testing out specifically this car and all the design choices we made for it. So we're getting excited for that. But for 2020 planning design, we're taking advantage of the time that's been given to us. It's kind of out of the norm, especially for our competitions, to have a whole 2 months to do basically design. It's kind of one of the fun parts of the competition. But basically one thing that's been an issue that Hayden has addressed as well, and that's a reoccurring issue for, I feel, any organization, and especially stuff like this with design projects with students, is knowledge transfer and passing on what we've done and what we know to the next generation of kids on the team. So we actually found that we could make a Carmen page, which is OSU's online teaching resource. So it's basically what all students log into, and then they will actually interact with their teachers and their classes and complete assignments on this program. So basically we can make creating pages and documents referencing all of our designs and all the methodology and stuff we've learned over the years on the team. And it's kind of interesting, specifically with all the stuff we do with Baja and EcoCar and Formula. We don't necessarily learn these specific examples in class. So it's nice to have a resource where we can put all this stuff and then quiz students on it and give them a learning path to get over some of the basic learning curves that come with racing technology and composites and fabrication, stuff that's not immediately intuitive to some students. Also, along with that, we think it's a huge thing in terms of exposure and growth, since every single student is interacting with this platform. Once they get added to our page, they'll actually have a mobile app where they can take quizzes and look at pages and learn on their own time. They don't actually have to be at the shop to get all the experience that they need. So we're actually really excited about that, and we've been putting stuff together for that, and we're hoping to release some stuff to all our general members in the middle of this summer once we get past all of our virtual competition stuff. And then another big challenge is going to be for our next car. So we do design and fabricate a car every year, and it takes about a 9-month cycle, I would say, in terms of designing it and building it and then testing and competing with it. But with the COVID-19 stuff, there's going to be some unforeseen expected challenges that we're trying to plan to deal with. And like I said, we do have quite a few members on the team that have been here for 3 or 4 years and are looking to get put everything they've known to the test and make something really well. So it's kind of hard to control those ambitions, because every young engineer is very ambitious in what they can do with the amount of time they have. And we certainly know that, and I'm pretty sure every student team on the in the student projects can attest to that. So controlling those ambitions, but also using the experience is going to be one of the biggest challenges for this year, because we do have all this time. And we are very excited about design and stuff like that. So thankfully, once we get this car done, we actually will be able to use this car for the next competition year. So that's going to be part of the plan as well. Yeah, so I just want to thank everyone for coming out and like listening to our presentations. It's really nice to see alumni coming back and viewing all the stuff we do. It's very encouraging, and especially all of you guys in the companies that sponsor us as well. SAE, or our formula team, we had a design review last year around September time, and we're hoping to have one earlier. And I think with all the experience that everyone's gained from Zoom and using these online platforms, we hope that hopefully some of you guys can make it out to that and see what we've been working on all summer and what our plans are for next year. So yeah, thank you guys, and it's a pretty cool presentation you got together, David.
Thank you. Questions for Jacob? Okay, no, seeing none. So we're moving to EcoCar.
All right, let me get my. All right, hopefully everybody can see me and hear me now, but I'm part of the Ohio State EcoCar program. My name is Christina Corbara, and I'm currently one of the engineering managers for the team. So a very big picture overview of the presentation. I don't know if we're covering this a little bit, but it's a 4-year advanced vehicle technology competition sponsored by the U.S. Department of Energy, General Motors, and MathWorks is a new headline sponsor, where it's challenging 12 different universities to rebuild a 2019 Chevrolet Blazer to increase the overall fuel economy as we're electrifying it and making it a hybrid, as well as the new part of the competition for this one is to integrate connected and automated technology. So we're in the process of building a level 2 SAE system with features like adaptive cruise control and lane keep assist. And then the last goal is to target the mobility as a service market. So we're actually trying to target them as our customers. So it's a 4-year competition. And then the first year, which was last year, was our design year. So we were figuring out which components were going to go into the vehicle, as well as designing the vehicle. This year is currently our integration or build year. So we normally are in the garage a lot, and we did make a lot of progress before COVID. So I'm going to share with you guys the progress we made so far. So in August 1st, our Blazer arrived to CAR. You guys can see it on the screen. And then we started by actually installing sensors on the vehicle, because our first deliverable was to do some baseline vehicle evaluation with the sensors. This one, you can see that we're actually building it, putting it actually into the vehicle. And then we actually went out to the Transportation Research Center and we drove the car. This is kind of one of our ABS tests. So we had a bunch of vehicle testing to just see what our baseline vehicle drove with, as well as what the sensors were able to detect, so they could start with some data while we're actually building the vehicle. And then this was our vehicle integration. We started out, you guys can see the engine was no longer in the car. We took that out. You guys can see, this is just a bunch of pictures I was gonna kind of just show, but we are doing some high voltage integration of wiring. Here, they're making a hole in the vehicle actually. So this is where our energy storage system will go. So there's some more pictures. This is some of the fabrication for our energy storage cable. So that was the hole we designed. This is where our rear electric motor goes below here, but this is the actual table that the energy storage or the battery pack will sit on, as well as this is just some of the fabrication work done at CAR that we did in the back building. You guys can kind of still see our car is pretty torn apart still. Our interior never made it back in, but this is where we're at. And then, so right before we left, we were able to get the battery pack into the back seat. It's not wired in or anything. but we were also able to integrate some of our inverters, as well as our engine was integrated successfully this year. Then we also did a bunch of component level testing. This is some of our energy storage system, our battery pack testing we did. We were able to use the high voltage dyno car, where we were able to do a bunch of different tests just to make sure our battery acted as we were expecting it to. We were able to turn it on, turn it off, check the capacity of the test, as well as we did some thermal testing. This is one of our test rigs that we made. This was specifically for the high voltage air compressor. So we actually just spun the air compressor for like maybe 10, 20 seconds just to make sure we were able to command it at specific speed. So we have a lot more testing still to go, but we were able to actually test each of our components individually to make sure that they were going to function to get basic functionality. This is actually the competition vehicle on our chassis dyno with the new engine that we had put in. So we were able to drive about 100 miles on the chassis dyno just to make sure our engine was functioning as intended. We were able to shift the transmission and everything else. So just some basic functionality checks that we were able to perform. And then overall, some of our outreach that we were able to perform this year, we had a bunch of different youth outreach events, 15 youth outreach events, 14 community events, 12 influencer events, and 6 publicity events. Over the past 2 years, we've had the opportunity to reach out to about 5,000 people. So that's a big part of our competition, is just making sure that we can engage a bunch of people, talk about the future of mobility, as well as this program. And then this program also, there's been 10 graduate theses, 5 undergrad theses, and a bunch of academics related to it. And then last but not least, overall, our competition results, we don't know yet. Everything has been only through deliverables, so we didn't have a virtual competition or anything. We had the opportunity to present videos and stuff for some of our we wrote a tech report and everything else, but we'll be finding out how well we did in July with regards to the competition. Everything, I think, is expected to start back up next school year, but they're obviously waiting to see how COVID turns out. And then in the meantime, I know a lot of people have been talking about what they've been doing, but we've been doing a lot of our software development still. We've been doing a lot of documentation to make sure that the knowledge transfer is okay, because we do lose, I think, 8 students of our team leads before next year. And then we're also pretty anxious to get back to car as soon as we can to finish the actual vehicle build and to get the vehicle functional. So with that, I'd like to say thank you for listening. I'm up for any questions, as well as this is kind of one of our virtual team meetings. So.
Any questions? Well, our final presentation is Dave McCook's going to give us an update on the Buckeye Bullet.
All right. Can you guys see my screen all right?
Not yet.
Well, that's interesting. It says I'm sharing. Figures I'm the only one that can't use the technology.
Yeah, really.
How about now?
There you go.
All right. Well, I was asked to give a brief update on the Bullet program. Things have definitely been a lot quieter the last couple of years, but they haven't gone away completely. I know we're over the allotted time. I think we sent out to some people, so I'll try to be quick here, but just wanted to let you know a little bit about the team's activities. To start, I think most of the people on the call are pretty familiar with the Bullet or have heard about it in the past. I just pulled a couple of my favorite pictures to walk you a bit through the story. In a different lifetime, a few years ago, I served as the team leader of the Buckeye Bullet and worked pretty closely with the development team. This program was actually kicked off by Dr. Rizzoni back in 1993. In those days, it was an open-wheeled racing vehicle in the Formula Lightning series. Ohio State raced for nearly 10 years, completely dominated that competition, won every national championship ever awarded, and more than 50% of the races. This was a lead-acid battery-powered race car, and we can dig up ESPN footage. We have it. I've even seen some great purple windbreakers from that era out at the races with the team dominating some of the big name competition from around the world, around the country. And statements like electric vehicles are the future, the industry is really going to harness the torque and the power and the capabilities of electric machines. And so these are topics we've been working on for many years. I got involved at the very tail end of the Buckeye Bullet 1, the next vehicle there, which was our first land speed car, and set the US record, which it still holds, for a battery-powered vehicle, our first vehicle to go over 315 miles an hour. And it has just been really neat over my career. I still consider myself reasonably young, but over the span of the time I've been working in electric vehicles from 2004 on, the paradigm shift from, media questions would be like, is this a joke, or where's the extension cord go? Is that why the vehicle's so long to spool the cord? And how could this ever be a viable?
Uh-oh.
EV really becoming the default, the cool factor and big performance. What was that?
You broke up a bit. You're back.
Okay. Been really neat to watch that progression, but we did the 3 land speed vehicles you see here with different battery propulsion systems, hydrogen fuel cells, all these vehicles going over 300 miles per hour. And in fact, every electric vehicle that's ever set a record over 300 has been built by students in our shop. We race these vehicles out at the Bonneville Salt Flats, so big place in Utah where we have tremendous distance. And basically depends on the rule set, but it's an average of 2 runs, sometimes both in the same direction. For the international rules, you have to go in both directions within an hour, and pretty intense to just do the job of getting to that speed, but then to service the vehicle, we do an 80% recharge, slowing from speed, packing parachutes, doing thermal conditioning on all the systems, bypass chillers, quite a sprint to get everything in that hour. So there's, engineering design comes up not only for the max performance of the vehicle, but to meet the duty cycles of the turnaround. Just a couple shots from Bonneville if you haven't had the pleasure to be there. This is the Salt Flats during Speed Week. So it's about a 50 square mile area on the Utah-Nevada border. What you see here is the start line, so a few hundred cars. It's first come, first serve during the week, so probably 500 to 700 teams will participate, and you go out at 5 and 6 in the morning to get in line, and then whoever's up next gets to have their time on the track. That group of cars you see off in the distance here in the left is about 3 to 5 miles away, and that's the pit, so that's where the 700 teams are set up, and it literally runs from mile 3 to mile 5, so that's kind of the scale of things out there. The long course that we run on is about 7 miles. And there are multiple courses for other lower speed vehicles, but we'll always stick with course number 1 here, the long course. So a lot of people that know about the sport or land speed racing, Bonneville, this is what they think of when they think Bonneville, sort of classic cars, and you will see these in droves. Thousands of people flock upon Wendover for this event each year. And I actually just got a message today that they are going to have the 2020 Bonneville event. So there will be some new safety precautions, but they pointed out that it's one of the largest areas that you can social distance in the country. So they are inviting everybody to Bonneville. If you've never had the chance, it's an amazing trip. But some of the classic Bonneville cars here, but you will see everything. These are some traditional race cars converted to run at Bonneville, anything from performance vehicles and sprint cars and dragsters. My favorite category, the special construction stuff. So these are purpose-built vehicles, from the smallest of streamliners that you can barely squeeze a small human in to try and go fast. This is an all-electric motorcycle. This is actually a belly tanker from a World War II plane. So bodywork is typically very expensive. So these guys just bought a proven aerodynamic shape and stuffed a giant motor in it, and those things are going over 300 miles an hour these days. So cool experience. This is also the home of the jet cars throughout the 60s and the 70s. The race to 300, 400, 500 miles an hour all happened at Bonneville. And then you always see some unique engineering innovations, from sending semi-trucks over 200 miles per hour. I think this was a big experiment in traction versus drag, so always opportunities to learn there. And this gentleman actually runs a race team. He's in a wheelchair, but he created a racing bike that he could drive his wheelchair up onto and still ride the motorcycle. So plenty of cool things that you'll see at the Bonneville Salt Flats. The vehicles we talk about comparing ourselves to, prior to us, the White Lightning was the fastest vehicle ever, and that was our initial goal, was to beat this world record, which we did first actually with a hydrogen-powered vehicle in 2009, and then many times since with electric vehicles, battery-powered vehicles. there's categories for piston engine, wheel driven. They're all in the mid 400 mile an hour range. And then the jet cars are quite a bit faster. They're up near 800 miles an hour, but we've always kind of eyed the wheel driven records against the piston cars. The latest quest was actually kicked off in 2013, which was to go 400 miles per hour for the first time ever with an EV. In all of history, only 9 vehicles have gone 400 miles per hour. The stat our driver loves is that more men have walked on the moon than have driven a vehicle over 400 miles per hour. So that's been the goal for quite a long time now. We've built an excellent vehicle that's capable of doing that. Completely custom engineering in every system on the vehicle, from power electronics and motors, energy storage systems, aerodynamics. We've really struggled getting the vehicle out on the track and having good years at the track to validate these things. So for time, I'm going to skip ahead, but unfortunately, out of our trips to Bonneville from 2013 to 2017, we saw a lot more of Lake Bonneville than we did the dry salt flats. So we had some really rough years, and it's been bad the last decade for the salt flats, a lot of flooding and tough times. Here's some pictures of sort of the daily being out there, still trying to hope for a chance to race. The first time I ever saw this much water and people still talking about trying to race 2 weeks later, I thought they were insane. But we experienced it. This is about a week later. We already started, it looks more like we're at the beach than the salt flats. And 2 weeks after that, it was a dry course and we could run. But we've had a lot of challenges with the surface. It's very thin, been a lot of water problems, and we have a very heavy vehicle. And so we did eventually get up to a new world record at 342 miles an hour. That was about a 100-mile-an-hour improvement over the existing world record. Top speed over 358. We returned one more year in 2017 and had a great pre-event, and the day that the world racing was supposed to start completely got rained out and sent home again. So that is the last time the vehicle ran at speed. Our data shows us if we have the track that we need in terms of distance and everything else, that we're well positioned to go 400, but finding the right surface for that has been a struggle. So since 2017, we pivoted to looking at some other options. I'll come back to that in a moment. Just wanted to close out the presentation here. Great opportunities for our students. Personally, one of the most memorable for me as a student, we had President Obama come and spend some time with us. It was super cool for the whole team, but lots of high profile exposure, the chance to really do out of the box thinking and design systems people have never thought about, and do things like film commercials and work with amazing teams in industry. During our hydrogen program, we actually side by side worked with the team at Ford, who set a hydrogen record in a production vehicle. That was really cool to work with an OEM and do development on advanced research, right next to the teams, working hand in hand. Really, really neat experience. And for me, both from when I was young on the team, looking forward to jobs in the industry, and now looking back at students that have come through the program, seeing where they end up and the great things they're doing is just the most rewarding part. For specifically, these are some of the places people from the Buckeye Bullet team have gone. Our aerodynamicist actually has 6 world championships with a Formula One team. We have people all over the electric vehicle industry, of course, but also aerospace, from building jet engines and airframes, working on advanced technologies, clean fuels, and more and more, a lot of people headed to Silicon Valley. So working on the next wave of technologies that I think will transform all of our lives. So very, very cool for us to track what our great alumni are doing. See some of you here tonight, and to connect with them is always something we greatly enjoy. So little update on the team before we close out here this evening. See if I properly stop my screen share. I can demonstrate here with my camera how quick what we're trying to do. So we spend a lot of our time here at the Bonneville Salt Flats, and we want to make the giant jump to a new area, which looks a whole lot like the Bonneville Salt Flats. This is the Bolivian Salt Flats behind me now. So one of the big challenges I mentioned for the team has been finding the right surface, and we had the neat opportunity a few years ago to go down to Australia and look at sort of the second best salt flats in the world in terms of size and availability. We were trying very hard to put together an event, but the logistics were just very complicated. Last year, we were able to send a team down to Bolivia to look at the largest salt flats in the world. And to put it in perspective, Bonneville's a huge place, but it's not even 1% the size of the Bolivian salt flats. And where we measure the salt in Bonneville in fractions of a millimeter in some cases, they're looking at meters and meters of salt. So we could set up a 20-mile track that had more than 10 feet of salt below us for the whole track. So that's kind of become a big focus of the team. In the background, while we haven't been out racing, we have kept several grad students and visiting scholars active on the project. One of the things that we were able to do this year, I can't say a lot about, but there was a little bit of a public announcement that our partner on the Bullet program, Venturi Automobiles, launched an electric motorcycle program. And we can say that we did a lot of design support for that, including the energy storage systems. And that bike was actually scheduled to ship out to Bolivia right now. And that was going to be the test event to see if we could come back with the Buckeye Bullet in the near future. So to prove out all the logistics of getting down to Bolivia. Unfortunately, COVID-19 brought that to a screeching halt, so the Bolivia trip's off for this year. It's my understanding Venturi's thinking pretty hard about heading to back to Bolivia next year. They're going to do some demonstrations with the bike at an airport or another location just to show the capabilities of the motorcycle. In the meantime, we've been looking at optimizing the vehicle. You know, we really kicked off this design in 2012, and things have changed in the electric machine and the battery world. On one hand, the vehicle is fully capable of doing the job and getting to 400, but on the other hand, we know there's an opportunity to improve upon the systems. So one of the big things we've been working on is potentially replacing the motors. We've talked to a few different companies. We thought we were really close to a pretty cool solution, but unfortunately that's not going to be possible right now, but we're talking to a few different groups about developing a custom high-powered machine. And there's definitely a lot more industry interest in these technologies. So if any of you are connected to groups that would like to continue that conversation with us, we're still exploring. I think it's very likely that you will see basically the same Bullet car with maybe a few key powertrain components out on the salt flats again, and hopefully the not too distant future. So had some great support from around the world, a number of different institutions that have sent some visiting scholars to spend time with us. As well as some graduate student support at CAR that have kept the torch going and the vehicle right there ready to go. So very, very excited for future opportunities and still hope to be the first to get to 400 miles per hour. So I'll pause there if there's any Bullet questions.
All right. Well, thanks everybody.
One more thing. If there aren't any questions about the Bullet, just wanted to put a real quick plug in for our outreach activities. So we, as many of you know, kicked off a summer camp a few years ago and are continuing to progress on that. Unfortunately, due to the COVID-19 situation and the university rules, we are not going to be able to have in-person summer camp this year, but we are going to be doing a shorter virtual event. The good news is, since it's on Zoom, we can have as many people as we want, currently up to 1,000, but more than that if we have to. And I think what we're looking at is an afternoon in the labs at Ohio State. It looks like we're going to have our key labs open by the time camp was scheduled for the end of July. And so what we're thinking right now is to do 5-minute bursts in each of the core technology areas. So in the battery labs and the automated vehicle labs, we'll try to keep it moving so we don't have too many people falling asleep on us, but we're going to do a couple hours. Really a plug for STEM education, automotive engineering, and the work we're doing. We're going to broadcast that to all of you, all of our industry partners. Like I said, there's no limit on the number that can attend, so we want to send it far and wide and have it a big recruiting event to get people thinking about going into engineering, going into mobility, and doing it at Ohio State. So we're very open to any inputs or ideas you have on that. We're starting to shape up a program. The other last thing I wanted to mention for our camp, we successfully won a grant around alternative energy and clean energy and clean mobility. And so we were able to actually add a new activity that we're really excited about. For those of you close to automotive development, we have a small autonomous robot kit, and we're just procuring those supplies. It'll be a MATLAB controls base with an introduction to automated vehicles. We're going to do some construction in the lab on the vehicle itself. And so we're using this time when we're not able to work with our high school students in the labs to develop some good programming for the future. So a lot of exciting things coming in the outreach, which is our pilot right into these motorsports programs. So thank you all for your support in that area. And definitely let us know if you want to get involved in any way, or if you have people you'd like to invite to those programs. We're always here for you. So.
All right. Well, that's all our formal presentations. If you haven't signed into the our sign-in sheet, I think everybody did, but if you didn't, it's at the top of the chat. I can repost it if you need it. Let me know. Lori Herman, who might be having mic problems because we haven't heard a peep out of her, says wonderful update from all of our student teams. Thank you to all for all you. Oh, can I hear? I can hear you. Go ahead.
Yeah, I don't know what was wrong before, but I'm here. I've been here the whole time. I've listened into everything, and everybody is fantastic. Thank you guys for everything you're doing. And from the Alumni Club, I'm very proud of all the students. I think all of your teams are awesome. I love being the unofficial cheerleader for your teams. And if and when I can, I will travel to your events and be your cheerleader. So let me know when you're going and where you're going, and I'll try and be there.
Perfect. Thank you, Lori. So I think at this point, if we don't have any other questions, I think Eileen thought that we'd have some people from the West Coast on. I don't know if that actually happened. So
if you could try it. Lori's here. I got Lori to join. Lori's technically in Michigan. Hey,
I know Lori well, and we talked before you got on. So yes, thank you for recruiting her. And there's no more formal presentations left, so it's just open discussion. Or I thank everybody for sticking. I know we went way over time, but I thought it was very interesting, so I thought that we'd let the students go. Don't forget the students. This is important. If you want your $50, you gotta do your duty of getting us receipts, and I will make sure you get reimbursed. Any last comments, Giorgio? You want to say anything besides serenade us? He's muted.
No, I was unmuting myself. Now the music we do on Tuesday nights. I was just keeping my fingers warm. I just wanted to say thank you. It's great to see you. And one of these days we'll be up there to see most of you in Detroit in person, I'm sure. But for now, we'll make Zoom do, and it's great to see you.
So just for the students that are on, the OSU Alumni Club of Detroit gets to host events, which I explained to you earlier. We get money to spend. And one of the categories is student retention. And we get to do, well, this fiscal year, we were able to do 3 per category. And the event that we planned that we thought would be a blast was during the auto show week, which, as you guys probably know, was switched from the middle of dreadful winter in Michigan in January to June. And just as a side note, I was thinking about this back. If the auto show would have happened in June with all those people from China coming here, the numbers of deaths and the virus spreading in Detroit would have been horrific. So it was just ironic that it was switched to June. The idea that we had as a club, which we will hopefully be able to still do maybe sometime in the near future next year, was to host an OSU alumni event in Detroit with the students that come to the wonderful Detroit Auto Show that's finally going to be in the warm weather next year. Knock on wood.
Hey, Dave, I think the other message I'd like to send to the students is if you are considering a job in automotive and you are considering moving up to Michigan, we've all been there. It was a scary move for most of us to consider moving up to Michigan, but just be reassured that there's lots of us alumni up here and we're here to support you. It's not that scary of a world, and it's actually a little bit fun to be in enemy territory, especially in recent years, but there is a whole host of us up here, so you're not going to be alone. I didn't know anybody when I moved to Metro Detroit, but I've since made a lot of friends, and the OSU Alumni Club of Detroit is so large and so wonderful that we'll be able to introduce you to a host of people also.
That's a good point. We have over 4,000 alums in Detroit. It is one of the most active and actually benchmark club in I'll call it the world, because we've had response from people all over the world asking about some of the things we do. This event is an event that involving the students on Zoom and all that maybe, who knows, other clubs might ask us to do, ask you guys to do it too. So we as Lori mentioned, we all did the scary leap of coming to Michigan. I did it in '81. Bob did it in the '70s, and Paul Shapiro was on. He did it in the '60s. and it's actually a nice place to live. And Lori mentioned that it hasn't been that bad. My tagline is, it's a great time to be a Buckeye in Michigan, because we kick their butt all the time, and they are really, really getting mad. So it's fun.
Much easier now than when I first came, Dave.
Yeah, the 90s, not Buckeyes in the 90s was not so pleasant. We got abused by U of M those years, and for the few of us that were here during the 90s, Michigan didn't let us forget our record against them. But boy, it's been a blast. Especially this last week, boy, Harbaugh's just been on a rampage about this thing. Been loving it in the press.
Like for the West Coast, I can tell it's been, it's a little different on the West Coast. If you're thinking about automotive on the West Coast, at Hyundai or Mazda, even Honda has an office out in LA, Tesla. The camaraderie is kind of like all the Big Ten people do get together. It's different. So, but it's a really good, it's a different experience. I've been out in California since 2006, but I go back to Ohio every now and then because I still do have friends in Columbus. Yeah, but moving's not easy. I do miss Ohio though.
Well, thanks everybody for coming and joining us. And students, remember, you get your receipts to Hayden, and let's stay in touch. This and for everybody, it's been recorded. So if you need a copy of it, I did record it. Yeah, and yeah, Darren just piped in that the students, you guys did a fantastic job. Thanks, congratulations, and good luck with the rest of your school. You are, yes. Round of applause. Michelle is right. You guys are living through, we are all living through a crazy time, but being a student during this crazy time, I know, is even extra crazy. So have a wonderful evening. Everybody stay safe.
Thank you so much. Have a great evening.
Thanks, David.
Yeah.
Bye.
Bye-bye.
Dave.
All right, bye.
Thank you.